this video I'm going to look at a couple of very classic multi-stage events that we can see when we're looking at probability. One of them is when we have coins being flipped, and the other is dice being rolled. Now, when we flip our coins or we have something where there aren't too many options, a tree diagram is a great way to go. So we would have our head, tail, head, tail, head, tail. So on the first flip, we would get a head or a tail. Then if we got a head the first time, we could have the options of head or tail second time. If we got a tail the first time, head or tail the second time. We can then write down those outcomes or the sample space, and they're the 4 combinations that we could get. Obviously we could extend that and go to 3 times or 3 coins being flipped, and look at that. We can then work out our probabilities from that because we've got 4 total options combinations altogether, so each of these ones would be 1 on 4 as the probability. But then if we said we wanted to say the probability of getting 1 tail, and we didn't matter which order that came in, then we could say that's 2 out of 4 or a half as that probability. When we do our dice roll, there's more combinations. So obviously we could do the tree diagram and set that up and have the 6 combinations coming out and then 6 off each of those, but that's a lot to write. So our tables are more commonly used to show the combinations for that. We can also go through, because a lot of times with the dice roll, you're asked for the total that you'll see. So you could go through and add that total. That pen's a bit light. So we would put the total of 2 there, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, and look at those totals and answer questions related to what total comes up on the dice roll. So we've got a total of 36 outcomes there. And so then we can use that table to work out different probabilities. They're the most common ones that you will see for your multi-stage events.